Assalamu alaikum guys, welcome back. This is Shafat Khan on your screen. All right guys, so today we are going to start out with chemical bonding. All right, a very important chapter of your MDCAT, chemical bonding, MDCAT chemistry, sorry, bonding. Right, so let's begin. All right, so first of all, we need to define what a chemical bond actually means. So what do we mean by chemical bond? Chemical bond is actually, it's a sort of a force of attraction, actually, a force of attraction between two or more atoms or ions. Okay, atoms or ions. That's it. That's the simplistic definition of a chemical bond. So what is a chemical bond? It's just a force of attraction between atoms, or it can be in between ions. Atoms are what you guys know as a neutral species, whereas ions are the charged species, right? Ions can be of two types. They can be positive or can be negative charge, whereas the atoms are always neutral. Now, why do atoms actually need to form chemical bonds in between them? They can exist independently, right? Why is there even a need to form chemical bonds in between them? So now we are going to first discuss this concept. Why do we need a chemical bond? Why can't atoms exist on their own? So basically, the major reason, a one-word answer to this would be due to stability. Okay, now I'm going to explain what stability actually means. This is the answer. Why do atoms form chemical bonds? Answer is stability. Basically, the atoms themselves independently are usually not stable. Atoms are not stable independently, except for which atoms? Except for a special group which is known as, except for the noble gases. Okay, noble gases are basically the group 0 elements or the group 8 elements, right? The group 8A elements actually, group 8 elements, which includes helium, neon, argon, krypton, xenon, radon. Helium, neon, argon, krypton, xenon, and radon gas. Radon gas is actually a radioactive gas, so we don't discuss about it much over here. But all the other gases over here, these are highly stable gases, and they do not need, they do not need chemical bonds. Okay, and the reason why they don't need chemical bonds is because they are stable on their own, right? They are stable without, they are actually, these are stable without the need of a chemical bond. But all other atoms of the periodic table, they do need, all the atoms of the periodic table, but all other atoms of the periodic table, they do need some sort of chemical bonding in order to attain stability. Now we're going to talk about stability in a bit more detail. If I were to ask you to define what stability actually means, so basically stability is the tendency to exist, the tendency to exist. Okay, if anything is more stable, it will be in a greater quantity. More stable means more quantity, whereas less stable means less quantity. It's that simple. All right, now what is it that's present in these gases and not present in all the other atoms of the periodic table which makes them stable? When you look at these noble gases, helium, neon, argon, krypton, so you guys might have already studied this earlier in your lower classes, that these gases, the noble gases, actually have a completely filled valence shell, right? Valence shell is basically the outermost shell of an atom, as you guys know, outermost shell. And if the outermost shell contains either 2 electrons or contains 8 electrons, then in that case it's considered to be stable. Actually, I won't use the term completely filled, because atoms, different valence shells can have different number of electrons, but I can say that they have either 2 or 8 electrons in the octet, 2 or 8 electrons in their outermost shells. So if any atom either has 2 electrons or has 8 electrons in its outer shell, most of the time it's going to be stable. Okay, 2 electrons are present in helium and 8 electrons are present in the outermost shell of all the other elements over here. All right, now this shell which contains 8 electrons is known as an octet, whereas the shell which contains 2 electrons is known as a duplet. All right, now if I were to talk about the hydrogen atom over here, hydrogen atom has 1 electron and 1 neutron, sorry, 1 electron and 1 proton and no neutrons, right? If I were to ask you how will the hydrogen become stable, well, it actually needs 1 more electron in order to attain the duplet configuration, right? So, and we know that hydrogen actually has only one shell, one s orbital, right? It only has the one s orbital that can have a maximum of 2 electrons only. So it needs 1 more electron in order to fill it. Where will it get that 1 more electron? It will get 1 more electron by forming a chemical bond with another hydrogen atom by receiving an electron from the other hydrogen atom. And now these electrons, this type of bonding is actually known as a covalent bond. Okay, covalent bonding, which we will be talking about in a lot more detail later on, but this is just an example that a chemical bond, a sort of a chemical bond is formed by which electrons are shared in between them, and this sharing of electrons results in the completion of their duplets. All right, so this is how hydrogen attains its duplet configuration, and once hydrogen attains its duplet configuration, then it exists in that form. In nature, you will find hydrogen molecules rather than hydrogen atoms. Why will you find hydrogen molecules? Because in these molecules, each atom has 2 electrons in the valence shells. Valence shells. And since each atom has 2 electrons in the valence shell, this means that the duplet has been completed. And if the duplet has been completed, then that simply means it's stable, right? If we talk about all the other elements, they'll attain the octet configuration. All right. So now, as a general rule, what is a chemical bond? If I were to ask you what is a chemical bond, so you are to answer that chemical bond is any force of attraction between 2 or more atoms or ions. Okay, force of attraction between 2 or more atoms or 2 or more ions. Okay, why is it formed? In order to attain stability, actually formed in order to attain stability. And if I were to ask you what stability was, so stability was the tendency to exist. All right, if something is less stable, it won't be formed. Okay, it will not be produced. But if something is more stable, it's gonna be produced in a greater quantity, right? This concept of stability is very, very important, super important, all right, for your later studies. So this was about the chemical bond. Now we can have multiple types of chemical bonds formed in between different types of atoms, different types of molecules, and multiple other stuff related to the chemical bonds. But before we move on to them, I'll first discuss what energetics of the chemical bonds are. Energetics actually refer to the different energy changes that take place while forming a chemical bond. All right, so basically whenever you are forming a chemical bond, 2 atoms, let's say these are the 2 atoms, and we need to form a chemical bond in between them. I'm not actually going into the detail of the type of chemical bond that is here. We can have multiple types of chemical bonds, right? We can have a covalent bond, we can have an ionic bond, we can have metallic bonds, we can have uh, dative bonds, meaning coordinated covalent bonds, etc. Multiple bonds can be can be formed, but I'm not going into the types of chemical bonds because that will be covered in a lot more detail in the upcoming videos. But over here now, it's the energetics, the energy changes that are taking place during the formation of a chemical bond needs to be referred to. All right, so basically if I have 2 atoms over here, let's say I have 2 hydrogen atoms over here, there are 2 types of forces that will exist in between them. First of all, I need to form a chemical bond, right? Chemical bond needs to be formed. Bond needs to be formed. Now, this chemical bond actually means we are trying to form a force of attraction. a force of attraction. We are trying to form a link between two atoms, right? Force of attraction, a link which is needed, which can hold the two atoms together and prevent them from moving apart from one another. And in order to allow them to exist in the most stable state, most stable state. Now, this is what we actually want this atom, these two atoms to do for us, right? We want them to link to one another and become stable and exist. But this force of attraction is not the only force that is present in between two atoms, actually. We can have two types of forces. There are attractive forces, which are actually the major dominating forces of a chemical bond, and there are repulsive forces as well. Yes, repulsive forces in between two atoms. Okay, two atoms, they can repel one another as well as attract each other. So now, guys, remember one thing: the energy that is needed, or I should say, before I refer to the energies, in order to form a chemical bond, the total attractive forces, they must become more than the total repulsive forces. Only under this situation can we form a chemical bond, okay? Repulsive forces. And it makes sense, right? Because if the attraction in between the two atoms is more than the repulsion in between them, that would actually mean that the atoms would stay with one another. They'll stick to one another. If the attraction is less than the repulsion, then the atoms will not stick to one another, right? They'll be repelled from one another. And by the way, why do we have attractive and repulsive? Why do we have repulsive forces actually? Repulsive forces, well, there can be multiple reasons to explain that. If you think of it this way, you've got nuclei in there in atoms, right? The nuclei are like charges, they are positively charged. So the nuclear repulsion can be a reason. And attractive forces are basically the forces which are present in between the electrons. Basically, I told you in the beginning that a chemical bond is actually formed by the electrons. Okay, just remember this fact, that most of the times you'll see a chemical bond being formed by the electrons, and electrons are negatively charged species. Okay, now electrons are negative. Okay, let me take another diagram. Let's say these are the two atoms we have, and there are certain electrons over here. Just an example, okay? This is not a special type of a bond, just an example to explain a concept over here. Now, for attractive forces are basically the forces in between these positively charged nuclei and the negatively charged electrons. This is a negative density, and these are the positive nuclei. So basically, the force of attraction in between them, these are the attractive forces. Whereas, what are the repulsive forces? Basically, these nuclei, they are positively charged, right? And like charges, they always repel one another. So the nuclei, they'll exert opposing force, repulsive forces on one another. So the nuclei will try to repel one another because they are like charges, but the nuclei and the electrons, they'll try to attract one another because these are unlike charges. Now remember, to form a chemical bond, these attractive forces, they must become more than the repulsive forces. This is a general rule. Attractive forces must become more than the repulsive forces. Only under this situation can you form a chemical bond. A chemical bond, no matter what type of chemical bond it is, whether it's a covalent bond or an ionic bond or any other bond, a chemical bond can only be formed if the repulsive forces are more, if the attractive forces are more than the repulsive forces, okay? And then what's the ultimate goal of a chemical bond? The ultimate goal is to provide stability. And how is that achieved? Well, it is achieved if the atom attains a duplet configuration. Duplet means it can attain 2 electrons in the outer shell, or if the atom attains an octet configuration. Octet meaning having 8 electrons in the outermost shell. All right, there are a few exceptions, but this is the general rule, okay? So for any atom to be stable, any compound to be stable, the atoms must have either 2 electrons in the outer shell or 8 electrons in the outer shell. This is known as the octet rule. Octet rule, okay? But octet rule is not indefinite, okay? It doesn't apply everywhere. The reason for that is because there are certain chemical compounds, which actually have more than 8 electrons in the outermost shell and less than 8 electrons in the outermost shell, but they are still stable. Let's take an example. Okay, before, okay, this is PCl3 basically. In PCl3, we've got one phosphorus and three chlorine atoms, and they are linked to one another by a special type of chemical bond known as a covalent bond. Okay, and each covalent bond contains two electrons. This is one covalent bond, this is second, and this is the third one. Now, if you look at the outermost shell of phosphorus, it only has six electrons in here, and six electrons actually means that the these are six electrons. Six electrons means they are less than eight, right? They are less than eight. So in this case, we say that the octet has shrinked. Okay, there is shrinkage of octet, shrinkage of octet. And so this shrinkage, even though there is shrinkage, but this phosphorus is stable in this form. Okay, similarly, we've got AlCl3. Even though again it's electron deficient, but still it's stable, because aluminum also has three chemical bonds over here, and it has only six electrons in the outermost shell. All right, so that's the reason why the octet rule is not indefinite, it keeps on changing. All right, actually not changing. The octet rule applies on most of the cases, but it doesn't apply on all the cases. Okay, there are a few exceptions to the octet rule, and this is one exception. Similarly, we also have PCl5, another compound. Now in PCl5, what actually has happened, we've got five chemical bonds over here. Okay, five covalent bonds, Cl, 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 Cl. Five covalent bonds actually means there are 10 electrons in there, because each covalent bond contains two electrons. Right now, 10 electrons actually mean that there is expansion, not contraction this time, expansion of octet. Right, even though the octet has expanded, even though there are more than 8 electrons, but it's still stable. Right, so again, octet rules exception. Right, so there are a few exceptions to the octet rule as well, for stability. Now we've talked about stability, we've talked about the chemical bonds, energetics. All right, and energetics, we've talked about the forces. Now you can also talk about, or you can also assume the same concept to apply on the energies. Okay, basically the energy which is involved in attracting them must be more than the energy which is involved in repelling them. Or you could also think of it in another way. If an atom, sorry, two atoms have to become stable, there's another concept that you must know. For high stability, the potential energy, which is also known as enthalpy, enthalpy can sometimes be referred to as enthalpy. Potential energy must be as low as possible, as low as possible. Okay, this is something I want you guys to learn. All right, I'll explain this in a bit. Potential energy actually refers to the energy which is hidden within the atoms, within the bonds of the atom. Right, so now if there is an atom, let's say there are two atoms linked together by some sort of attraction, and their potential energy is low, then we can say that it's highly stable, highly stable. But if but if the potential energy of two atoms is high, then it's going to be unstable. Okay, if the potential energy of an atom, of two atoms, let's say we have an atom A and atom B, okay, let's call them compounds A and compounds B. If the potential energy of compound A is more than the potential energy of compound B, then we can say that compound A is less stable. Okay, not more stable, less stable. Okay, more energy means less stability. More energy means it's more excited, it can readily react and convert into some other form. It's not going to stay in this form, its tendency to exist in this form is going to be less. Okay, and less energy means it's going to be more stable in that particular form. Okay, it's going to stay in this B form, it's going to stay in this compound form. Okay, it's not going to change in, or it's not going to convert, or it's not going to react with some other compound and convert into some other compound easily. All right, so that's how the potential energy is linked with the stability as well. Right, the greater the stability, the lesser the potential energy, and the higher the potential energy, the lesser the stability. All right, and then finally, uh, yeah, finally, I'm just going to discuss about an important point over here, that the potential energy must be minimum for atoms to be the most stable. All right, for a molecule to be the most stable. And that's actually exactly what happens once you form a chemical bond. All right, a chemical bond is formed only if the potential energy is minimum, okay, not maximum, it's minimum, right? If the potential energy is high, it's not gonna form at all, okay? Chemical bond is needed for stability. Remember, I told you this is how you link it with stability. And so if potential energy is minimum, that automatically means it's gonna be highly stable, right? And that's exactly what the chemical bond will tell you, or chemical bond will actually help you. And this chemical bond, this chemical bond helps atoms achieve either 2 electrons or 8 electrons in most of the cases. And after achieving these two types of configurations, the atoms become highly stable, all right? Except for a few exceptions like PCl3, PCl5, AlCl3. In these exceptions, we've got multiple other factors. Okay, we've got actually not multiple, just two factors. There's a phenomena known as contraction of octet and expansion of octet that occurs. All right, so these compounds, they don't actually follow the octet rule as strictly. All right, they do not follow the octet rule. These are exceptions to the octet rule, but yet they are stable. Yet they are stable. So that's it for this video, guys. In the next video, we are going to talk about the trends of, um, uh, we are going to talk about the atomic sizes, atomic radii, ionic and covalent radii, etc., etc. Right? So stay tuned and meet you guys in the next video. Thank you.